So today we're going to look at how to represent data and information with a two-way table. And we've already seen two ways to represent data, and those two ways are either with tree diagrams or Venn diagrams. And all three of these, tree diagrams, Venn diagrams, two-way tables, they all have the same information on them. But some of the information is more readily available in different forms. So let's look at an example, and let's just say that you have a class of 26 students. And of these 26 students, you ask them two questions. First one, you ask the students whether they are male or female. And so let's just say, here are the answers. We'll have red be female, blue be male. And an obvious way at this point would be to use a tree diagram to split them up. So we say, okay, let's look at all the females and all the males. So there are the females, there are the males, and we will split them up and make a tree branching off them, and we basically count them up, and so there are 14 females, there are 12 males, and that's what we'll put on these two branches, showing that one branch has 14 females, the other branch has 12 males. But now I said there were two questions. So the second question is whether the student would prefer a cat or prefer a dog as a pet. So if we ask them that, we'll see that here are the responses. We have some number of cats, some number of dog responses for females, and different number of cat and dog responses for males. And so what we will do is we will create a branch at each end. So we will say, okay, there were 14 females. Now let's split up how many females chose cat and how many females chose dogs. And same thing with males. We had 12 males. Let's split those up. So each of these, this top branch is only dealing with females. This bottom branch is only dealing with males. And I'll take the cats. There are going to be 9 females that prefer cats. We'll take the dogs. There are 5 females that prefer dogs. We'll take the cats for males. There happen to be 7 males that prefer cats. We'll take the dogs for males, and there happen to be 5 males who prefer dogs. And we'll just basically take those and write them in a very similar way to what we had here. So 9 cats, 5 dogs, 7 cats, 5 dogs. And so what this quite literally means, this number here, means that 9 people chose cat that were also female. We see them right here. This is 5 people chose dog that are also male. And you could flip-flop and have the cat-dog question here and then split those up male-female. A common mistake is when people are asked how many students are in this. Let me get rid of the cats and dogs. So some people try to say that there are 14 plus 12 plus 9 plus 5 plus 7 plus 5 total people here. This gives me a total of 52 when I add it up. But this is not correct because these 14 females are exactly the same as these 9 and 5. So really, to find the total number of people, I would either add 14 and 12 and get 26, or I could add 9, 5, 7, and 5 and still get 26. So that's one way, and it's a very intuitive way. It's something that it makes sense when you start saying, I asked the first question, let's split them up, and then let's split that group up even more. But it's not the only way. So let's look at another option. So we have our 14 females, our 12 males, and this time let's go ahead and make a Venn diagram. So the way we make a Venn diagram is we're going to go and say, all right, we have these female cat, dog, these male cat, dog, and we'll make a rectangle. This rectangle will contain every person that we are surveying here. And so, in this rectangle, we will make two circles. Here's another issue that commonly comes up. So, when people see this, a lot of times they say, okay, we'll put male here, we'll put female here. And people tend to do this because they use Venn diagrams in things like English class to compare and contrast. Like, what do males have in common with females? What is just a male trait? What's a female trait? I could do the same thing with cats and dogs, but that's not what we're doing here, okay? If I am trying to figure out what sets happen, or what sets each of these belong to, I will have one circle that deals with the gender of the respondent and another circle that deals with the type of animal. So it should be, you could do instead of female male, you could do instead of cat dog, but it should be one of them dealing with the first question, one of them dealing with the other question. And what happens here is students might say, wait a second, I see a female circle, where do I put the males? Well, the female circle inside this circle, actually let me change colors, let me do the same colors that we have. So inside this circle, I will put all of my female responses. So inside this circle will be all the female responses. Outside of this circle will be all of the male responses. So those are going to go out here. And so I don't need a male circle if I assume, and again, for simplicity's sake, I'm just going to say genders of male or female. I know that we can have others, but if it's in the female circle, we'll call it female, and if I want something that's not a female, I'll put it outside of that circle. Same thing for cat. I only allowed cat or dog in this, and so if a person chose a cat, it'll be inside the cat circle, and if someone did not, it'll be outside. So let's see where I would put these responses. So the 9 females that chose cats go inside the female circle and inside the cat circle. The 5 females that chose dogs, they're inside the female circle, but they're not inside the cat circle, so that means that this would be dogs. The 7 males who chose cat are not in the female circle, so they're in the males, and they're in the cat circle because they chose cats. And the 5 males who chose dogs, they are not female, so they're outside of that, and they're not choosing cats, so they're outside of there. And now, most of our Venn diagrams that we'll see in our class will not have these little symbols on them. They will instead have numbers, just to show how many. So instead of having 5 symbols, 9 symbols, 7 symbols, 5 symbols, they'll have the number 5, 9, 7, and 5. And again, this has some things nicer than the tree diagram, but notice I don't have any of the totals. In order to find out how many total females, I need to do some addition. Not terrible, but it's not readily available. So let's look at the third way, the new way, the way we're seeing today. So I still have my females and my males that chose cats and chose dogs, and a two-way table is basically just a table that you would put in any document. So I have one way, a second way, and I can put the gender question going one way, the pet question going the other way. So female, male total, cat, dog total. And now I'll just do the same thing. So in this section right here will be all the females that chose cats. In this section here will be all the females that chose dogs, and so forth and so on. So males that chose cats, males that chose dogs, and again, in our class, we won't draw two-way tables that have images in them. We'll have the number, so I don't need 9 little kitty cat faces. I'll just put the number 9. And similarly for all the rest, 9, 5, 7, and 5. But here is the really nice thing. So these were the same numbers we saw on the Venn diagram. But the two-way table can also keep track of all the totals. So if I see 9 females chose cats, 5 females chose dogs, that must mean that there are 9 plus 5, a total of 14 females. And I can add these together to get the total males, and I can add these down to get the total cat and total dog choices. So we can see, okay, 16 total people, male and female, chose cats. 12 males chose something. And in addition to that, I can see how large the entire class is by adding the 14 and the 12, or the 16 and the 10. And notice, they had better add up to the same number. So it's a great check to make sure you did things correctly, because if this 14 plus 12 didn't add up to this 16 plus 10, getting us 26 on both ways, then we messed up somewhere, and one of the numbers in here, at least one of the numbers, is incorrect. So this right here, is our new two-way table. And I tend to like the two-way table a lot because it has all the numbers I could want in there. It has each individual number. It has the totals going either way. So when we start doing more with probabilities, I can ask conditional probabilities or any probability question and usually be able to pull the numbers directly off of here. So let's pull this all together. We have 3 different ways we're going to represent this, 3 different diagrams. The first one was the tree diagram, and we see that we split up female and male and then split up cats and dogs. The second way was the Venn diagram, where we had a rectangle, and you could choose these circles differently. Again, this could be a male circle instead of a female circle, or a dog circle instead of a cat circle. Just like this could have been cat and dog, and this could be female and male. But the numbers will be the same throughout. And finally, we had the two-way table. And I like this because it has everything. So for this right here, for the tree diagram, I have some of the totals. Like, for instance, right here, I know that there were 14 total females. I know that there are 12 total males. And you can see that's the same 14 and 12 that we have in this two-way table. But in the tree diagram, the way I've done it, I don't have a number showing up how many cats. I'd have to say, okay, I have cats here and cats here, and 9 plus 7 gives me 16. In the two-way table, that's already right here. That's already included, so it's kind of useful. But you'll notice there are lots and lots of similarities. In every single one of these diagrams, we have the individual values. We have this 9, 5, 7, and 5 in all 3 of the representations. They all mean the same things, just shown in different spots. It's just which one shows the most information.